optimization. Actually, Fiona, do you want to hit the light on the left? That might work better for today. Yeah. I think. I don't know. I'm kind of wondering if this screen is like losing brightness or whatever, because it used to seem brighter. Maybe it's just because I'm at an angle. I don't know. So optimization is word problems that we're going to be using the first derivative, second derivative test on, which sounds terrible, right? But this is nothing like the word problems you had for related rates. I'm positive as soon as I said word problems, that's what sprang to your mind was those word problems, which were pretty large. These are about finding a maximum or a minimum answer. That's why they're called optimization. And we do that with first derivative test, the relative maxes, relative mins. Okay, so find two positive numbers such that the sum of the first and twice the second is 64, and whose product is a maximum. The main thing I want to get across to you, whatever you're being asked to maximize or minimize is going to be your primary function. That's the primary goal of the problem. So I usually try to set these up with a primary and secondary set of information. The primary is always going to be whatever you're trying to maximize or minimize. And I don't care if you call it a primary and secondary, that's just what I call it. There's no real terms that we need to know. I consider this a primary because the equation you write feels like it has no answers, okay? So it says whose product is a maximum. Well, the product is what we're trying to maximize, and we're multiplying two numbers, right? So call them whatever you want, x and y. And this is why it kind of feels like it's unsolvable, because you've got all these variables. Secondary will always have information that you're able to substitute with, which means the secondary traditionally has numbers. And again, this is just how I view it, how I've done it. I've seen it taught multiple ways, just whatever's fine. This problem is extremely small, so there's almost no way you can not realize what the other set of info is, right? It says the sum of first and twice the second, so sum meaning that they're added. The first, I guess I'll just call x, but it doesn't matter. Twice the second is 64. The secondary equation is only going to be used to substitute and make the primary easier to do. That's pretty much it. So, should we solve for x or y? Which one's easier? X, for sure. Okay? Yeah, that would help. Trying to talk and write doesn't always work correctly. My brain doesn't always put them together. Okay, I'm going to use this to substitute into the primary problem. So instead of x, I'm going to write 64 minus 2y times y. I'm not going to have enough room here. I'll probably actually multiply them out to make it easier. Jeez. Thank God you're here today. When my brain starts moving forward, but I'm still writing the previous stuff. How do I find maximum answers? Okay? Critical numbers are where max and mins happen at. So let's find the critical numbers to start with. So P prime, 64 minus 4y, which leads me to have critical numbers at, I guess, just 16. Come on. How do I figure out if that 16 is a max or a min? Oh, bummer. Well, it definitely is on the test we're going to be taking soon, so you definitely want to know that one. Justin? Back him up.
You go like underneath 15 or above and see if it's increasing or decreasing.
Okay, absolutely. That is one method. So we could do a number line and test before and after to see if it's, I mean, for us to have a maximum, we would hope it would be increasing then decreasing. Okay, there is also the second method. Ooh, that'll be on the test as well. You can plug a critical number into the second derivative to figure out if it's concave up, which would be a minimum, or concave down, which would be a maximum. We know the critical number means it's going to be the tip. So it doesn't matter which way you choose, right? I'm going to do second derivative because this equation is easy. If this equation was difficult, I would definitely choose the number line method. Okay, so P double prime is -4. That's what I meant when I said it's a pretty easy equation, right? Now, whatever number I plug into the second derivative, the answer is still going to be -4. So P double prime of 16 gives me -4, which means it's a relative max. Now, it feels kind of weird that we are doing relative max. Technically, we're looking for absolute max, but it kind of depends on the situation that you're working with. This particular one said it has to be positive numbers. Now, I didn't do anything with that because, well, none of the information ended up negative, so it didn't matter. If I would have found two critical numbers and one was negative, I would have ignored the negative one and only used the positive. But there is no end. Like, the numbers can be as big as you want. But then well, I guess technically what's the biggest it could possibly be? Well, no. It doesn't tell us they have to be integers. It just says numbers. I was going to say 64 is the biggest possible number we could have, 64 times 1. But that's not true because if you take 128 times a half, that's still 64. So you could actually have as big a number as you wanted. So this ends up being our only real possibility. So we're frequently going to do relative max and min because the testing is easier. But if you run into a situation where there can only be certain numbers, well, then you would do absolute max and min, like test the endpoints. But this one, that'd be dumb. So we basically just found out that, wait, actually, what did I find out? Who should we go with? Justin, pick somebody.
22.
Brendan, what did we find out? What's the answer to this question? Okay. Didn't answer the question, though. What was the question looking for? Yes. So what do I answer? Where'd you get 24 from? Which one is which? Which one is the 16? Oh, perfect. Because we said so over there. Yep. And we were working with y's. Okay, x is 64 minus double the y. So 64 minus 32 would give me 32. So now if I did x plus double y, I would get 64. That's a bad circle. Better circle. Okay, this is what optimization is going to be. The situation that you're dealing with is what's going to make the problem easier or harder. But the process is going to be the exact same for every question.
Could you explain the primary and secondary thing?
So one sentence in the problem is always going to ask you to find something to be a maximum or a minimum. That's our primary equation because it's what we were asked to optimize. And so we were always going to have to do the derivative of it to find critical numbers and do relative maxes and mins. So the one that it says to maximize or minimize is always the primary. Secondary just means it's going to be a second piece of information to help you solve the primary. So you don't have to call them primary, secondary. I do to keep it straight in my head. Okay, let's move it up a step. A rancher. Well, we're moving on to Yellowstone here. A rancher plans to fence a rectangular pasture adjacent to a river. Well, this definitely sounds like something I should draw because I'm an excellent artist. River. A rectangular pasture. Oh, wait, I gotta draw green. That looks like a rectangular pasture. Just a single rectangle? Yes. Oh, well, let's draw a little grass here. Art skills. I'll have you guys know I passed drawing class at college. Now, I did actually like taking that class because it was good for practicing how to draw three-dimensional shapes. And that's definitely something I need to do a lot of. So, okay, so we've got a pasture. The pasture must contain 180,000 square meters. So that is telling me the area is 180,000 square meters, correct? Well, I guess I'm going to label these because I'm going to have to do something with that. What'd you say?
It's the same problem, just with 180,000 instead of 64.
Okay. Why is that bad? If you'll notice, a lot of the questions in our packet do that. They keep the same situation, but then change it around or find something different. So area be 180,000, so x times y is 180,000. This is definitely not the same problem. Now, this tells me right away the fact that I have a number there, that's going to be my secondary equation because it's got numbers, it's not. So what dimensions would require the least amount of fencing? So that's what I'm minimizing. Apparently I am minimizing perimeter. So my perimeter, bless you, perimeter would be 2x plus y. I want to minimize that. And this is what I have to substitute information, which is actually going to make the problem harder. Should we solve for x or y? Do you guys care? You don't care. Okay, sounds good. So I am going to substitute y with 180,000 over x. Now, in terms of I'm doing derivatives, I probably shouldn't write it as 180,000 over x. How should I write it?
80,000 extra negatives.
Yeah. I'll write it so I can do power rule. Or you don't have to rewrite it, you could just do it in your head, but I'm assuming a lot of you would rather rewrite it. Okay, so P prime, because that's how I'm going to minimize, is 2 minus 180,000 x to the negative 2. If I did quotient rule, I still should have had minus 180,000 over x squared. Shouldn't matter. Now, I do need to solve this to find critical numbers. One critical number technically is 0 because it's undefined at 0. But why would I not care about that 0? We're not going to have a fence with a dimension of 0. That'd be stupid. Although, that would be kind of interesting because then you would have really long, if x was 0, y would be like really long around that river. Okay, so the other crit number, how do I find that? Who should we go with? Who went last? Brendan went last. Who's going to help me find the other crit number? 14. Helen. How do I find it? Yeah. That sounds like you're trying to ask me. Oh, that's not a very good answer then. Oh, how do we find critical numbers? Okay, good. So I'm going to take this equation and make it equal to 0. We already found the undefined at x equals 0, and that's the one we said didn't matter. I'm going to erase this because I'm running out of room, but so let's just find the crit number. How do I solve that? Oh, no, I don't. I want her to tell me.
You try to get x on the other side.
Okay, we can do that. How would you do that? I can't hear you.
Multiply it.
So multiply everything by x squared?
Yeah.
Okay, I can do that. Done? I don't think that's what you meant, but that still works.
Yeah. You can just.
You could have added that whole term to the other side. I think that's what you meant. And it still works, still same thing. But okay, so x squared equals 90,000. Is that 300? Okay, so x is plus and minus 300. That's my crit numbers. And I should immediately throw out negative 300 if I'm being smart, because a negative value for your fence just doesn't really seem right. So 300 is our only critical value. Ellen, do you want to pick somebody else? It's super hard for me to say your name slower. That comes out of my mouth as Ellen. Oh, okay. Looks like you're trying to start some violence on your. Oh, okay. I see incoming beef coming, but okay. What do I do from here?
Would you
We have two choices.
that if you like the drawing
So we can do that one. If you find the second derivative and you plug a critical number into the second derivative, it would tell you if it's concave up or down to tell you if it's max or min. The other option is we could make a number line with 300 in the middle and figure out if it's increasing, decreasing, before, after. I don't really have a preference. It sounds like you wanted to do the double prime because we did on the last problem is my guess. This equation isn't, I wouldn't call it easy or hard. It's like somewhere in the middle. The derivative would be negative 3.6 million. No, negative 360,000. That's bad multiplying. X to the negative 3. If I plug 300 in, am I going to get a positive or negative answer, Vivian?
you
Perfect.
300 into,
Oh. So negative 360,000 over 300 cubed would be a negative answer.
yeah.
I don't even need to know the number. Okay, negative answer though. Uh-oh, that's an issue. That doesn't seem right. Oh, what? It is, it's positive? Oh my gosh. Today is not going good for my brain. Let's pretend that I did the derivative correctly. And pretend that I wrote positive here in the first place. How many of you knew I did the wrong derivative but didn't say anything for like 3 minutes? Why? Why? All right. That's good, because if we found out that that value is a maximum, that kind of screws over our problem, because that's not what we were trying to find at all. And if that happens, then we would have had to try to figure out a minimum somehow from in between. We would have had to test a lot more values. Okay, but a positive gives us a minimum value, so that's good. So 300 is a min. That's what I wanted. That would have been a very good way to fact check myself, because as soon as I had a negative concavity, something wasn't working out right. And that would tell me I probably made an error. Vivian, who's going to help me finish the problem off? I assumed it was Elise, but I just thought I'd give you the chance to. What do I do from here? I got a number. Oh, okay. How do I do that?
You put, one says X,
Where? But you're correct.
the X, Y.
Perfect. The secondary equation is always going to be the one that'll help you find answers. So I get 600. 180,000 divided by 300 would give me 6 with 2 more zeros. How are we feeling on this so far? I mean, it's going to be the same process. I'm going to help you start the next one with the picture, because as soon as you look at the next one, then your heart immediately drops a little bit. This one's actually more of a real life situation though, because this is kind of like when they make pizza boxes. Now, pizza boxes, you don't maximize or minimize because that would be dumb. You make pizza boxes the size of the pizza. What they probably would maximize or minimize is how many pizza boxes to get out of a sheet of cardboard. So this one is a little bit different situation where you're given a sheet of cardboard and you're going to be asked to find a box with maximum volume from that sheet of cardboard. Are you trying to ask something?
Yeah,
Sorry, go ahead.
it's okay. I was just wondering why we have to read the double product. We already knew that X was 300.
We didn't know if that was a max or a min.
We
Plus,
have to put that in the answer.
yes, because you're going to get situations where you have multiple crit values, and sometimes they'll be like you'll have multiple answers. And so let's say we have 2 relative maxes. We'd have to figure out which one is the bigger max. Yeah, so you definitely want to find that information out. If there's only one critical number, it kind of limits us anyway, but we used it as a way to double check that I made a mistake anyway, so. Okay, so this one tells us, oh, I guess this is a metal box, whatever. Piece of sheet metal that is 18 by 30. Now the 18 is not this. 18 is from far left to the far right. And the 30 is from the very top to the very bottom. What size squares should be cut to make a box of maximum volume? So, this actually only has one variable, doesn't it? Because the side being cut out are squares, and so there's only going to be one. There's only one thing being asked, is how big is that square being cut out to make maximum volume? So that's only one dimension. I don't like this. I wanted it harder. But we'll go with it. Okay, our primary thing that we are trying to maximize was volume. What do I write for volume? No. It's not going to be 30 times 18 times x. It feels like it should be, but it's not. Nope. I'll write down the answer to help you guys, but I need you to figure out why. Shh, 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 shh. Did you not hear me say I'm going to write down the answer, but let you figure out why? No, I didn't even listen to yours. You might have been right or wrong. I didn't hear it. Why is this the volume? So if I were to actually fold up this box, if I were to actually fold up this box, it's not 18 across the bottom. It's 18 from the original piece of metal. And when you fold up the sides, this piece on the bottom was 18 inches long originally, but when I cut out x by x, I cut off a length of x on each side. So that's the 18 minus 2x. Each corner has those 2x's cut off. And then the same with the 30. When it's folded up, it started off 30 originally, but the length is now 30 minus the 2x's I cut out. So this would be 18 minus 2x times 30 minus 2x by x. Why don't you guys see if you can figure out what x should be to give you a maximum volume? Now this is technically a little bit easier because there's no secondary equation for the most part. Like there's only one variable to begin with. If it wasn't a square, then that's where it would be more work. I guess we could have said x times y, but that'd be silly.
Keep multiplying.
I'm officially declaring that I'm going to use a calculator to find this answer. I took out a 4 to make it simpler, and that's just not super helpful. I mean, I'm sure it factors, and I'm sure the answer is going to be a nice even number. But my track record today is not going great, so I'm just going to use calculator. So if you guys noticed, I factored the 2 out of each of the original factors, so that multiplying out was a lot easier, which made the derivative a lot easier. Oh, I was wrong. This is a quadratic formula one. Did I multiply something wrong? I hear somebody saying, how's he getting this? It's entirely possible I multiplied something wrong.
I did the number lines.
So, if if something needs to be solved with quadratic formula, I'm not going to have you do that on a test without calculator. I mean, not that it's impossible to do, but when you're using the quadratic formula for an exact answer, that doesn't really help you find a helpful answer, I guess. So in terms of these, you would want regular numbers rather than square roots. Okay, did somebody get something different then? Did you guys get the same derivative? Yes? I'm just worried I did something wrong because there's no calculator picture. Should we double check ourselves? Okay, so I factored a 2 out of here, a 2 out of here, so that gave me 4x. 9 times 15, I believe, is 135. Yeah. I didn't use a calculator in that part. Okay, and then I got minus 9x minus 15x to get minus 24x, and then plus x squared. And then they all had an extra x because of the x out front. And then when you're doing the derivative, I can leave a multiplier out front, so I ignored that portion, just put it with it. And then the derivative was relatively easy. With the same equation? I mean, if you have the same equation, we should have the same answers no matter what.
184 divided by 4 is 46, not 48. That's what
What is that?
I don't know what you're talking about.
okay, let me see.
Oh, you have a 46 on yours, not a 48?
I think I read it.
Because when I did the derivative of negative 24x squared, I just doubled 24.
The notes got the same thing as yours.
Okay,
Oh, the answer key? Oh, then I'm good. I can keep my license as a teacher. So I do want you to know ahead of time, I 100% will, if you're doing it by hand, I absolutely will be picking equations and setting up so it works out nice and straightforward. If you're not doing it by hand like this one, well, then it could be whatever. Now we have an issue though. What is our issue? We have two critical numbers. We have to figure out if they're both maxes or mins. And then let's say they're both maxes. We have to figure out which one is a bigger max or if they're the same. To be honest, I wouldn't be shocked if they're the exact same. So, and I haven't done it yet, but like if you think about a box, if you have a small x value, you're going to get a short box. If you have a really large x value, you're going to have a very tall box. Now, a really large x value doesn't really make sense because you're wasting a lot of the metal. And I would think that that would be a smaller answer, so I'm kind of expecting one of these to be a relative max and one to be a relative min, but I haven't done it. So I guess double prime, I don't know, neither one of these is a very good method. So negative 48 plus 6x. I guess that won't be too hard to calculate. So I'm going to try it for both numbers. So v double prime of 3.641. I could take out a 3, but I don't really. I'm not worried about it. So 6 times that is like 18 to 20, and that'll be a negative answer. So that's a negative second derivative. And if I put in 12.359, 6 times that would be like definitely more than 48. So this is going to be a positive answer. That tells me that 12.359 is a relative min. And I don't want that. So I would cross that out. And 3.641 is a relative max, which means 3.641 is the value I was looking for. And that's actually all I need to answer on this one because it only wanted to know what would be the x value to cut out the squares. It wasn't asking for the actual volume of the box. Who answered last? I don't remember. Who's going to help me answer the next question and the last question of the day? What would I do if the question actually asked for the volume that was maximized? Rather than just the x value to cut out.
Plug X into the original volume.
Perfect. You would plug x into the volume formula up here to find the actual volume it would create. Now this is a very realistic situation because that's how businesses spend less on the stuff they're buying. Like, think of Amazon. They've got a lot of different size boxes, and I'm sure they have a lot of different size pieces of cardboard they use to start with. They 100% would want to get the box with maximum volume over the box with minimum volume, and that would save them money. Now, I think we also know Amazon's not very good at like determining the correct package to put their stuff in, but the best is when they put a box inside of a box every single time. Okay, I'm going to stop here. Now, there definitely is more types of these questions. The main difference that I'm going to work with you tomorrow, the different styles, is these feel like word problems, like they're things you can visualize in your head. But there is other types of optimization questions that feel very different from this, even though you're doing the same thing. So that's what we'll do tomorrow. And optimization itself isn't terrible. It's just they're all different, but they're all done the same way.